Hello, we are the Team 7, and the members of the team are Luis Perez, Jorge Pineda, Jessica Ontiveros, and my name, Servando Negrete. And the situation we choose to discuss about is the ozone layer depletion. It has been scientifically proven how ozone depletion, which is the gradual thinning of Earth's ozone layer in the upper atmosphere, is mainly caused by the release of compounds containing gases, chlorine or bromine, from industry and the other human activities. The thinning is most pronounced in the polar regions, especially over Antarctica. Ozone depletion is a major environmental problem because it increases the amount of ultraviolet radiation that reaches Earth's surface, which increases the rate of skin cancer, eye contact, and genetic of and immune system damage. This is an environmental problem that should concern everyone due to the fact that the ozone layer protects us from the problems mentioned previously.
In the theoretical framework, there are many researches that have focused on the specific topic, starting from Dutch chemist Paul Crutzen, that in 1969 published a paper that described the major nitrogen oxide catalytic cycle affecting an ozone levels. He demonstrated that nitrogen oxides can react with free oxygen and atoms, thus slowing the creation of ozone, and can also decompose ozone into nitrogen dioxide, oxygen gas, and other types. Many scientists and environmentalists in the 1970s used Crutzen's discovery to assist their arguments against the creation of a fleet American supersonic transports, the SSTS. They feared for that potential emission of nitrogen oxides and water vapor from this aircraft will damage the ozone layer.
One of our main problems today is that, granted, the use of CFC gases has been declining since we knew that it was bad for the ozone layer, but still, many people use it today, and its control isn't best. If we keep this kind of lifestyle, it could lead us to many health problems, such as skin cancer and eye cataracts, due to the lack of UV protection from the ozone layer. One of the proposals we have is to start campaigns regarding the correct use of this gas, and also ask for laws for better regulation of the CFC gas. One way to do this is to start reward programs and ask for people to stop using any equipment that has CFC gases and to change them for more environmentally friendly options. Our hypothesis is that if the implementation of more regulations regarding the use of hydrochlorofluorocarbons were implemented, along with the use of a more friendly gas, then the ozone layer depletion will decrease and all its symptoms and conditions regarding this depletion would also stop altogether.
Testing the hypothesis. Action to diminish the depletion of the ozone layer, especially concerning the use of hydrochlorofluorocarbons, can be made by both citizens and industries. In order to help the decrease of greenhouse effects and the complications brought by the lack of UV ray protection. A clear example of these nations taking action regarding the ozone depletion is the Montreal Protocol. Since the Antarctic ozone hole was the first in 1980, nations joined forces to restore the ozone to be in a better state in 1987. The Montreal Protocol on substances that deplete the ozone layer is an international treaty, was established to protect the ozone layer by reducing the production of numerous substances that are responsible of the ozone depletion. More than 180 nations agreed to ban ozone-depleting chemicals. Since the implementation of this protocol have shown the chloride compounds in the stratosphere are decreasing, and chemistry climate model protection showed that if all the countries and their corresponding industries keep contributing following this protocol, that means that they do not produce something that releases this dangerous chemical, the global ozone should return to 1980, that is, was before the first hole in the ozone layer, and this level should be perfect about 2050. This case proves that if taking adequate actions, the problematic can be successfully reduced. Even so, some improvements are yet to be made in order to take care even more actions to the depletion of the ozone layer. For instance, the first gas that was used to substitute this harmful substance also destroyed the ozone layer, but in a less level of harm. A beneficial substitute of the chlorofluorocarbons is still in development. Okay? Some ways society can also help. Yes, they are really helpful if we can stop using the deodorants, the gases, the aerosols, the cleaning solvent that releases this type of chemical. They are usually in the household products, in our daily life products. But if we just do not buy them and use more ecological products, we can afford a great quantity of protection to the ozone layer depletion. As a conclusion, sustainability has become an important factor for our future. It is important to take care of the ozone layer depletion due to all the benefits that it has to the humans and also the animals and plants. So it is necessary to implement the actions as reducing the hydrofluorocarbons that are present in refrigerants, aerosol, and plastic products. If we take these actions, we can reduce considerably the ozone layer depletion, and if we implement even more programs, we can obtain a great result.
"15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.